Okay, so lesson 6.0C, triangles and angles. So we're going to be measuring the sides and the angles of this triangle. So what you want to do is notice how your protractor has at the bottom part a ruler part. So the top portion is in centimeters, and then the bottom portion of your protractor is in inches. So we're going to be measuring in centimeters because that's what we're asked to do. So we're going to be measuring in centimeters. So I'm going to take this right side of my triangle. So I'm going to rotate my protractor around, line up from vertex to vertex. And it looks like this length of the right side of my triangle is 8 centimeters. Okay, then I'm going to take the base and measure it. So from vertex to vertex. Now the good thing about centimeters is that each mark is 1/10 of a centimeter. So that means this would be 8.6 centimeters. Okay, and then the left side of my triangle is going to be, it looks like it's 5.7 centimeters. Okay, now to measure the angles, I'm going to do the same thing I did with the angle measures in the previous lesson. I'm going to line up my vertex. So I'm going to measure this right bottom angle first. So I'm going to line up the vertex with the center of the protractor and line up the base with 0 degrees. So 0 degrees would be using the top row to measure. So if I use the top row, I'm at exactly, looks like 40 degrees. Okay, so that means this right angle, the bottom right angle is 40 degrees. Then I move to the left side, and I'm going to measure this left angle here, the bottom left angle, and I'm going to line my vertex with the center of the protractor and my horizontal with 0 degrees, and I'm going to be using the bottom row to measure. So if I use the bottom row, I'm going to measure counterclockwise, and it looks like it's going to be 65 degrees. Okay, now I have to measure the top angle. So I'm going to shift my paper around, and it might be blurry because when I shift it, the settings might change. Okay, so if I line up my protractor with the vertex and the side with 0 degrees, I'm going to be using the bottom row to measure. So I'm going to measure counterclockwise, and it's going to be 75 degrees. Okay, so this angle here at the top would be 75 degrees. Okay, so now I write out the side measurements. I got 5.7 centimeters, 8 centimeters, and 8.6 centimeters. Then my angle measures were 75 degrees, 40 degrees, and 65 degrees. Now to check if I measured the angles correctly, if they all add up to 180, then that means I did measure correctly because the angles in a triangle add up to 180. So if you add 75 plus 40 plus 65, you actually do get a sum of 180 degrees. So that should tell you that you measured correctly. So if you're off, that means one of your angles was probably measured incorrectly. Okay, number 2. Oops, before I go to number 2, then we have to classify the triangle by the sides and the angles. So because none of the sides are the same, this would be a scalene triangle. And by the angles, that means whether it's acute, right, or obtuse. All of the angles are acute, so this is a scalene acute triangle. Okay, number 2. I'm going to measure the side lengths. So this top side on the top left would be about, looks like it's 7.6 centimeters. Okay, the right side here, it looks like it's about 4.2 centimeters. Okay, and then the bottom side, the base, it looks like it's 8.7 centimeters. Okay, now to measure the angles on the left side. Okay, I'm going to start with the left angle here at the bottom. Line up my vertex with the center of the protractor and my protractor, the horizontal, with 0 degrees. So I'm going to be using the bottom row to measure. And here's 0 degrees. I go up counterclockwise, so that would be 30 degrees. So this angle here is 30 degrees. And then on the right side here, the right angle, okay, I'm going to line up my vertex with my protractor, with the center of the protractor, and then my horizontal with the base of the triangle. And I'm going to be using the top row to measure because I line up my horizontal with 0 degrees. And I go up, and it looks like it's going to be 60 degrees. Okay, then I'm going to rotate my paper. It might get blurry because of the settings here. And I'm going to line up my center of the protractor with the vertex. And my horizontal is lined up with 0 degrees. I'm going to be using the top row to measure, and that's going to be 90 degrees. So this is a 90-degree right angle. So to classify the triangle, okay, so we'll do that in a moment. Let's label the side measurements. So the sides, we got 7.6, 4.2 centimeters and 8.7 centimeters. And then the angle measurements were 30 degrees, 60 degrees, and 90 degrees. So because we have none of the sides are the same, that means this would be a scalene triangle, and one of the angles is 90 degrees, so it'd be right triangle. So this is a scalene right triangle. Okay, so now I want you on your own to try numbers 3, 4, 5, and 6. So measure the side lengths, angle measurements, and classify the triangle based on the sides and the angles. And then I'll go over the answers with you in a couple of minutes. Okay, so here's the answer to number 3. So if you're off by like 1/10 of a centimeter, that's okay. Okay, so if you're off by 1/10 of a degree, no, 1/10 of a centimeter or plus or minus 1 degree on these, it's okay. So for number 3, you should have gotten that it's a scalene obtuse triangle. Number 4, isosceles right triangle. So there was one 90-degree angle and two sides that were the same. So that's made it isosceles and right. For 5 and 6, all of the angles were 60 degrees and all of the side lengths were the same. So if you got the same side lengths and you're off by 1/10 of a degree or so, you should be okay. So this is an equilateral acute triangle. And in problem number 6, you have two angles that are the same, and the side lengths also turned out to have two sides that are the same. So this would be an isosceles acute triangle. Any questions on the lesson you just did?